Hi friends, welcome back to another session on operating systems. We are into the second module where we are looking at the process management. In this, now let us see what a thread is and what a multi-threaded system is and see how the whole thing works. So let's deep dive into this multi-threaded system. So before looking into multi-threaded, let us see what a thread is. A thread is basically a smallest unit of execution within a process. That means there is one process, and that process, if it contains some part of the process that can be executed separately without depending on one another, then each of these sub-components can be separated and each one can be called a thread, and these threads can be made to run concurrently. So that's what we say a thread is. Here, a process is an independent program where each one will have its own memory space, but a thread is a lightweight sub part of that process, which means it will not have its own memory space. It will share the memory space of the process itself. So each thread under a process will not have a separate memory space for that, but it will share the memory space of the process. Now multiple threads in a process share the same memory as just discussed, and each one has its own register, stack and program counter. Because each one is running independently, each thread is running independently, therefore at any given instant, what are the values that are stored in that registers, we need to have a separate copy of that in the memory. So we need register contents to be stored in the memory. We need a separate stack for each one because each part of the code may be using stack, so we don't want to disturb one thread with another thread, so we have a separate stack for that. And we want to know what was the last instruction executed by a particular thread and what will be the next instruction to be executed. If that thread is allowed to have a CPU, so the next instruction to be executed is stored in the program counter. So each thread is working differently, independently, concurrently, whatever we say. Therefore each thread is at different position and we need to keep track of them. So each thread should have a separate program counter, each thread should have a separate stack, each thread should have a place to store their register values in the memory. But the code for the process is common to all the threads. So the code of the process is one copy and each thread is using the copy, so that we don't have to have multiple copies of the thread. We save the space. Then the global data, variables and all that will be one copy, so there won't be any confusion. Each thread is not going to have their own different values, so but there has to be some way to synchronize and all that. So we have some other issues when these are being used by the different threads simultaneously, then something we need to take care about synchronization and all that. So we'll look into that in detail in the coming sessions when we talk with memory management and all that. Then the program counter. So we look at this diagram, it's a bit clearer. So the whole circle is one process, and in that we looked at it's having two threads, thread 1 and thread 2. And because we are working with a single CPU system, then any given time one thread can execute, so only one thread will get a chance to work with the CPU. Therefore when thread 1 is working, thread 2 is not working. When thread 2 is working, thread 1 is not working. It's very clearly shown in the vertical timeline. You can see that when thread 1 is working, thread 2 is not working. When thread 2 is working, thread 1 is not working, and when thread 1 is working, thread 2 is not working, and so on. So this example talks about two threads. It can be same with any number of threads, but yes, any given time one thread is active because there is only one CPU which can execute the threads. Now looking at the difference between the single thread and multi-thread, whatever just explained was in words, so it can just uh, disappear from the mind, but a picture is worth 1,000 words. So let me just show a picture to clearly differentiate between a single thread system and a multi-thread system. A single thread system is one where we have the memory will contain the code, will contain the data, will contain the files that are open and all that. Then will contain the place to store the contents of the register. Will have a memory reserved for the stack, and the thread will be executing. So this vertical line is talking about the time the thread is working. In case of multi-thread system, yes, we can see that multiple threads are working concurrently, but if you look carefully, the upper three blocks, the code, data, file are common to all the threads. Register, each one has got a separate register place to store the contents of the register. Each one will have a separate place for their stack. Same way, each one will have a place to write the contents of the program counter, so that we know at what step each thread is running at any given time. So they will have the code, data, file, register, stack all are one set in the single thread system, whereas in multi-thread system there is only one set of code, data and files, only one set, but the registers, stacks, program counter are of multiple numbers, for one for each thread. So that's what a multi-thread system looks like. Now looking at one more confusion, that is single thread, single processor, multi-thread, single processor, and what about multi-processing? So that's just the same thing we have seen in the previous single thread, single processor. Here we have everything one copy, whereas when we have a single processor, multiple thread, then code, data and files are of one set, whereas each thread will have its own register, stack, contents to be stored in the memory. But in case of multi-processing, then each one is one process, so each process will have its own memory space which is going to accommodate code, data, files, register, stack and all that. So this is one process, this is another process, and in this case it is a single thread. Each process is working with single thread. It can be this also, each process can have multiple threads also. So in all, so today's operating system is quite complex. So it's a multi CPU, multi core, multi processing and multi-threaded system. So we can imagine how deeply it is built, and how much complicated today's operating systems are performing, and that's it. So as of now, that's what we have in stock. So keep watching. If you find this of any use, please don't forget to like, comment and subscribe, share with your friends. That's it for now. Thank you.